Okay, our last question is also a revenue question, but we're talking about oranges instead of money, but the principle is still the same. Now, an orange grove now has 20 trees per acre, and the average yield is 300 oranges per tree. So the revenue is the oranges, like the maximum amount of oranges. So the number of items are the 20 trees. The price per item is just the 300 oranges per tree. So our revenue or our output is going to be 6,000 oranges. So what they estimate is every time I increase the number of trees by 1, I'm going to decrease the number of oranges by multiples of 10. So if I have 1 extra tree, all of my trees are going to produce 10 less, probably because there's not enough room, there's not enough nutrients, etc. If I increase it by 2 trees per acre, I'm going to lose 20 oranges per tree. So we want to know what's the maximum number of trees I can have per acre to give the largest yield of oranges. So our revenue is going to be the 20 trees per acre, but I'm increasing them by multiples of 1 tree, times 300 oranges per tree, but I'm losing multiples of 10 per tree. So this is my new maximum revenue. So my maximum is going to be 20 times 3, 20 times negative 10x, x times 300, and x times negative 10. So let's write this in descending powers of x. So that'll be negative 10x squared. Combine my like terms is 100x plus 6,000. So I'm ready to complete the square, and I want to do that by factoring out negative 10. So I do that just from my x terms. So negative 10x squared divided by negative 10 is x squared. 100x divided by negative 10 is negative 10x. Leave myself some space, plus 6,000. So I'm going to go over here to my grid. So I have x squared. I take my negative 10x and I divide it into 2 equal pieces. Then I factor out the GCF of x, take out my leading coefficient of negative 5. I just check to see if I've done that right. X times x is x squared. Negative 5 times x is negative 5x. X times negative 5 is negative 5x. And negative 5 times negative 5 is positive 25. So inside the brackets, I'm going to add and also subtract 25, because 25 take away 25 is 0, and I can add 0 to any expression without changing its value. So let's look at my max, negative 10, and I'm going to factor my perfect square trinomial, which I know factors from my grid as x minus 5 times x minus 5, or x minus 5 squared. Now don't forget about the negative 25 inside the brackets. I'm going to take that out by multiplying negative 10 by negative 25. So that's 250 that I will add to the 6,000 that's already outside. So finishing this off here, all I have to do is combine my like terms on the outside, which is 6,250. So let's look at my vertex, opposite on the inside, straight up on the outside. So this is what my max or min is. This is when it occurs. So since I have a negative opening down, I know I have a maximum, and that maximum is my maximum revenue or output. So my maximum is 6,250 oranges. Let me try that again. So 6,250 oranges. And how do I do that? I do that by increasing multiples of 5. So what that means is I am increasing the trees per acre by multiples of 5. So I'm going to have 25 trees per acre, but I'm decreasing the number of oranges also by multiples of 5, which would be 250. So 25 trees per acre, each producing 250 oranges. 25 times 250 gives me my 6,250 oranges. So how many trees per acre? That would be 25, producing 250 oranges for a total of 6,250 oranges.